Greetings. This is going to be a lecture that is the second of two lectures on categorical logic. In the previous lecture, we covered what categorical claims are, how they're related to one another. We looked at the square of opposition. We examined the concepts of existential import versus the hypothetical interpretation of universals. And we also discussed the quality of being distributed and what terms in a categorical claim are distributed. So all of that, hopefully, is going to be useful to us as we look at categorical syllogisms. So that's what this particular lecture is about. And as with the previous lecture, all I'm going to do right now is go to my, what do I want here? Is this what I want? This is what I want, I think. Yes? Okay, well, sort of. All right. My homepage. Okay, so this is my naturally not so exciting homepage, but then we click on critical thinking, and this is our syllabus, and now we go to down to the set of notes. This is what we did last time, and here's what we're going to do this time, okay? So we're building on what we had covered in the last lecture, and we're going to be looking at major term, minor term, middle term, major premise and minor premise. They're all pretty straightforward, nothing too tricky there. Just as categorical claims can be put in standard form, categorical syllogisms can be put in standard form. And it's important to know what standard form categorical syllogism looks like and make sure that we're adhering to that conceit. We're going to talk about the mood and also the figure of categorical syllogisms. We'll be looking at testing for validity using rules, testing for validity using Venn diagrams, and then we'll do some exercises, okay? So this is how we begin. So we begin with this: major term, minor term, middle term, major premise, minor premise, right? Oh, did I actually explain what a categorical syllogism is? Well, perhaps I didn't. But anyway, a syllogism, we know, is an argument that has two premises and one conclusion. That's just what the word syllogism means. What makes a categorical syllogism is that all of the claims in the syllogism are categorical claims. Again, there are A claims, I claims, O claims, or E claims, right, from our previous lecture. So here's an example of a categorical syllogism. Some consumers are not Democrats. All Americans are consumers. Some Americans are not Democrats. So the first claim there is a categorical claim. It happens to be an O claim. Some consumers are not Democrats, right? So the particular particular categorical claim, an O. The second premise is an A claim. All Americans are consumers. And then the conclusion is it's another O claim. So we have an O, an A, and an O. Right? Now, the major term of a categorical syllogism is whatever term is the predicate of the conclusion. So to find the major term, you have to go look at the conclusion, look at the predicate term. In this case, it's Democrats, and so Democrat would be the major term in this syllogism. The minor term is the subject of the conclusion. So in this syllogism, the minor term is Americans. And then the middle term is the term that does not appear in the conclusion. It only appears in the premises, and that would be consumer in this particular syllogism. I remember the opening credits for Monty Python and the Holy Grail. One of the last characters they introduce is Sir not appearing in this film. So the middle term is Sir not appearing in the conclusion. All right. Now, once you identify what the major term is and what the minor term is, you can then go on to determine what the major premise is and the minor premise is. And as you might imagine, the major premise is whichever premise contains the major term, and the minor premise is whatever premise contains the minor term. Right? So here we are. Basically, it's the same idea. Consumers is the middle term, doesn't appear in the conclusion. Doesn't appear in the conclusion. Democrats is the major term because it's the predicate of the conclusion. And Americans is the subject of the conclusion, so that's the middle term, right? And so we have some consumers are not Democrats, that's our major premise. All Americans are consumers, that's the minor premise. All Americans are not, some Americans are not Democrats, rather. And there we go, right? Now, often what is frequently used in symbolizing a syllogism are P, S, and M for the terms. P indicating the predicate of the conclusion, the major term, S indicating the subject of the conclusion, or the minor term, and M indicating the term that does not appear in the conclusion, the middle term. Right? Okay, so far so good. Now, categorical syllogisms and standard form. The main thing you have to remember about the standard form of a categorical syllogism is that the major premise always has to go on top. So all Americans are consumers, and then saying some consumers are not Democrats, therefore some Americans are not Democrats. Notice that syllogism is a categorical syllogism, yes, and that syllogism is identical, logically indistinguishable from the syllogism we just looked at. However, this syllogism that we see on the screen right now is not in standard form. Why not? Because the minor premise is on top and the major premise is underneath. Well, you can't do it that way, right? So we're going to look at mood in a moment. But if you misconfigure your standard syllogism, you might get the mood wrong, or you might get the figure wrong. So in order to correctly identify the mood and figure of a syllogism, it's important that it be in standard form. Preview of coming attractions, the mood of this particular argument is OAO, not AOO. So skipping ahead, I guess, let's talk about the mood of a categorical syllogism. So the mood is basically just you list the letters of the, let me rephrase, you list the kind of categorical statements comprising the syllogism, and you list it from top to bottom. So the syllogism that we're looking at is OAO, that's the mood, right? You go, well, that's fine, okay, that's not very complicated. No, it's not very complicated at all. But notice, if you rendered the syllogism this way, you might think that the mood is AOO. Well, it's not, right? But that's because you've mixed, not you, but one has mixed up the minor and major premises. So that's one of the reasons why you must keep the major premise on top, right? Minor, no. All right, so I'm again pointing out that this is wrong, and that the right way to identify it is with the major premise on top. So this is correct, right? Democrats is the major term, Democrats is the major premise, right? Okay, so now, in a similar way, the figure of a categorical syllogism will depend on how the minor terms stack up, right? If the minor terms stack up on a slant that goes from upper left to lower right, then we call that first figure. If the minor terms stack up so that they're on top of each other on the right-hand side, in other words, they both appear as the predicate in the premise set, then this is called second figure. On the other hand, if the minor terms are both the subject of the premises, then we call that third figure. And if they're on a slant, again, that goes from upper right to lower left, then that's considered fourth figure. So depending on how the minor terms stack up, they are either first figure, second figure, third figure, or fourth figure. Now, this is a little mnemonic device that has been developed. I did not originate this, right? I borrowed it from other people. In fact, I think I learned it as an undergraduate when I was studying logic. But if you imagine a shirt collar here, right? Like a little button-down shirt collar. First figure, they're on the edge of the collar. Second figure, they're also on the edge of the collar. Then here's where the tie would be, right? Or lariat. And then if they're on the edge of this collar, that's third figure. And if they're on that edge of the collar, that's fourth figure. I hope that's helpful to you. It was helpful to me as an undergraduate. Right? But notice in this syllogism, the minor terms stack up this way. So that would be what figure? Do, 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 do. Hopefully you just said first figure and you would be correct. But now suppose the argument was presented incorrectly, not in standard form, right? Hey, wait, my notes don't have this correctly. Well, I can't fix them now, but suppose I had put this premise on top, right? By mistake. It doesn't belong there, but suppose I had put it on top. Well, then it would look like the middle terms are on the diagonal like this. And so you might think that this syllogism is in fourth figure, when in fact it's not. It's in first figure, right? So this is why it's not that big a deal if the figure is first, second, or third figure. It doesn't make that big of a difference. But not having it in standard form can mess you up if the syllogism is either in first figure or in fourth figure, right? Regardless, just make sure it's in standard form, right? So notice a couple of things. The mood and figure can be used to classify all possible categorical syllogisms. Note further that there are 4 different types of categorical claims, and each syllogism contains a total of 3 categorical claims. So that means that there are only 64 different possible moods. Right? If you start with AAA, AAE, AAI, AAO, right? If you just enumerate all of them, you exhaust them after 64. So there's only 64 possible ones. So those are the moods. Now, each mood can be in one of 4 different figures, right? And that means that when you multiply 64 by 4, you get 256. So that means there are only 256 possible categorical syllogisms. When you just exhaust all the logical possible configurations of categorical syllogisms, you find that there are only 256 in total. And I recall as, I think as a graduate student, just out of, I don't know, I guess I was bored, I actually diagrammed each and every possible categorical syllogism that's possible to do. Notice, because you don't have to diagram the conclusion, that's just not what goes into it. I didn't actually have to do 256, right? Because all I had to do was diagram the premises and I was done, regardless of what kind of claim the conclusion was, whether the conclusion was an A, an E, an I, or an O. The same diagram worked for all 3 of those, right? Because you don't diagram the conclusion. Anyway, you can do that if you like. Now, of the 256 possible syllogisms, only 24 are valid, right? So the vast majority of possible categorical syllogisms are invalid. They are not truth-preserving. Even if the premises were true, the conclusion might not be true. Now, of the 24 valid forms, only 15 are what are called unconditionally valid, and 9 are what's called conditionally valid. So we'll talk about that in a bit, but now let's move on to using rules to test for validity. There are 6 rules that you can use, that you must use in order to test a syllogism for validity, right? So if a syllogism does not violate rules 1 through 5, but it does violate rule 6, it is said to be conditionally valid. But if it doesn't violate any of the rules, not 1 through 6, then it's what's called unconditionally valid. Okay, so let's see. Rule 1. In a valid syllogism, the middle term must be distributed at least once. Now, if you're wondering what distributed, what does that mean again? Well, remember, it's in the previous lecture, it's in the previous set of notes, but in an A claim, the subject is distributed. In an I claim, nothing is distributed. In an E claim, both the subject and the predicate is distributed, and in an O claim, the predicate is distributed. So by the time you finish looking at your premises, you have to see whether or not the middle term has been distributed at least once. If it hasn't been distributed at least once, it violates rule 1, you're done, the argument's invalid, right? If it has been distributed at least once, then you have to continue checking for rules. Rule 2, in a valid categorical syllogism, any term that is distributed in the conclusion must be distributed in the premises. So you have to look at the conclusion and see if anything is distributed there. If nothing is distributed there, then you don't have to worry about whether that term is distributed above in the premises or not. So for instance, if your conclusion is an I claim, well, nothing's distributed in an I claim. And so you don't have to worry about whether there is any distribution going on in the premise set. But any other conclusion, yeah, you do have to worry about that, right? Rule number 3, in a valid categorical syllogism, if an argument has a negative premise, it must have a negative conclusion, right? So if I know that if either of the premises is an E claim or an O claim, then the conclusion has to be an E claim or an O claim. That's just the rule, right? So that's another rule to check for. The rule 4 is very similar, it's related. If in a valid categorical syllogism, if an argument has a negative conclusion, it must have a negative premise. Right? Now, I have seen people render rule 4, and they've combined rule 3 and rule 4 to say this. In a valid categorical syllogism, there are exactly as many negative premises as there are conclusions. That works. I think that separating them is makes it a little more conceptually clear. So that's what I've done here. But that raises an important point. Please use the rule numbering convention that we've outlined here. There's different ways of rendering the rules. There's different ways of numbering the rules. You could organize them differently, right? So we're using these 6 rules and we're using them in this order, right? Number 5, in a valid categorical syllogism, there cannot be 2 negative premises. Right? So as soon as I saw a syllogism with EE as the premise, right? Any mood that begins EE, I don't even have to look any further to know that it violates rule 5, right? Or EI, no, EI is not a problem, but EO would be a problem, or OO would be a problem, right? Why? 2 negative premises. It doesn't work that way. And then number 6 is the conditional requirement. In a valid categorical syllogism, any particular conclusion cannot be drawn from 2 universal premises. So if I have an A and an A, and then the conclusion is an I, that's a problem. It's a violation of rule 6. Now, it's a problem if one is making the hypothetical interpretation of universals. And think about it for a moment. There's no place for the X to come from if I'm starting with 2 A claims, or if I'm coming with an A and an E claim. They're both universals. There's no place for the X to come from if I'm making the hypothetical interpretation. If I'm making existential import or the existential assumption, that might not be a problem. And so there are certain argument forms that if this is the only rule that it violates, then it's called conditionally valid. It's valid on the condition that you assume the subject classes are not empty. You make existential assumption or existential import, okay? So notice many cases once I know the mood and figure of the argument in question, I can determine whether it's valid or not quite easily. For instance, no argument with the mood EEE is valid regardless. Well, it fails rule 5, right? No argument of the mood III is valid. Why? Well, because it fails rule 1. If all the terms are I claims, nothing's distributed. That means the middle term can't be distributed even once because all the premises are I's. And also if AAA is valid, why? It violates rule 4, right? Because I have two affirmative premises, but a negative conclusion. Well, that's not allowed, right? So, I suggest that you test for validity. And in order to test for validity, I suggest that you follow the following 3 steps. First, plot out your argument by mood and figure. Then underline any of the terms that are distributed so that you have a visual. That's a distributed term. Maybe you want to circle it or underline it or maybe highlight it. I don't know. And so if I've got AAA first figure, first I plot out all blank are blank, all blank are blank, all blank are blank, right? That's what the mood says, AAA. First figure means the M's are stacked up on that side of the shirt collar, right? So I stack, got my M's. Now I plug in my major and minor terms, major term on top, minor term in the middle, all SRP. Now I distribute anything that is distributed. In an A claim, the subject is distributed. The minor premise is an A claim, the subject is distributed. The conclusion is an A claim, the subject is distributed. And now I check for my rules. Does it violate rule 1? Nope. Does it violate rule 2? Nope. Neither 3, nor 4, nor 5, nor 6. AAA first figure is valid. Indeed, it is unconditionally valid. And as we learned long ago, this is Barbara, and Barbara is valid, and Barbara is valid every time we meet Barbara. Now, how about AAA second figure? Well, the first several steps are the same, except the M's don't stack up this way if it's second figure. The M's stack up this way if it's second figure, right? So notice it violates rule 1. Rule 1 says the middle term must be distributed at least once, but the middle term isn't distributed, right? So AAA second figure is not a valid argument form. It violates the second. How about AAI first figure, right? Well, again, it looks very similar to AAA first figure, right? So here's our M's, here's our P, here's our S, right? So the premises are the same. The conclusion is different though. Some SRP. Well, notice it does fail rule 6, right? In other words, there's no place for the X to come from if you don't assume that the subject class is not empty. On the other hand, if you could assume the subject class is not empty, then it does have an X to come from. So we would say it is conditionally valid. On the assumption there is at least one S, then I know that there is at least one S that is a P based on my premise set. Okay? All right. Venn diagrams. Okay, now this gets a little bit more complicated than the Venn diagrams we looked at a moment ago, or in the previous lecture rather. We have 3 sets, not 2, because we have middle term, minor term, and major term. So we have 3 sets. So we are going to use this configuration of the Venn diagram and the 3 overlapping circles. It's not the only way to render it. You could put the middle term on top, etc. There's different ways of rendering it. But for consistency, this is the diagram we're going to be using in our class, all right? And in this diagram, the middle term is in the middle, right? On the bottom, but in the middle, right? In our diagram, the minor term is on the left-hand side, subject of the conclusion, and the major term is on the right-hand side, predicate of the conclusion. So far, so good, right? And this diagram gives us 7 different regions. Region 1, 2, 3, 4, 5, 6, and 7, right? So we must first draw 3 overlapping circles to keep our diagrams uniform and representative of the actual relationships between the claims. We make the 2 upper circles represent the minor term and the major term, and the middle circle representing the, oh, I said that wrong. The 2 upper circles represent the minor term and the major term, and then the middle circle represents the middle term. This renders the diagram of having the 7. Notice the S circle includes regions 1, 2, 4, and 5. The P circle includes regions 2, 3, 5, and 6. And the M circle includes regions 4, 5, 6, and 7. So minor term, major term, middle term, okay? Not very mysterious. Now, how do we diagram it? Well, there are 6 steps to diagramming your circle or your syllogism, right? Step number 1, draw the 3 overlapping circles. Step number 2, identify the minor term and the major term and the middle term. Step number 3, label the minor term as the upper left-hand circle, the major term as the upper right-hand circle, and the middle term as the bottom circle. Again, there's nothing very challenging here. Step 4, determine whether you need to shade or place an X. Right? Recall that universals require shading and particulars require placing an X. Now, if you have to shade, you have to do the shading first. Before you do any placing of X's, you have to shade. If both your premises are universals, it doesn't matter which one you shade first, but you have to shade, right? But if one of your premises is a universal and one of your premises is a particular, then you have to shade first and X second. And if both your premises are particulars, you don't have a valid argument, but that's another story. Shade whatever needs to be shaded first, then afterwards place an X if the argument contains a premise, a particular premise. Then you put your pencil down. What do I mean by that? Well, you do not diagram the conclusion. You only diagram the premises. The whole idea is that if the premises entail the conclusion, then simply diagramming the premises is sufficient to show that the conclusion is, the conclusion should be diagrammed for you in a valid argument. On the other hand, if you diagram the premises and the conclusion isn't diagrammed for you, well, then that shows you that the argument's invalid. The conclusion says more than what the premises warrant, right? That's the whole point of using diagrams to determine validity, okay? All right, so let's do this one, right? No Republicans are collectivists. Some socialists are collectivists. No socialists are Republicans, okay? What's the mood of this? I'm not asking that here, but I'm going to just ask you because there you are. Well, the mood would be EAE. What's the figure of this? Well, double check. Is the major term on top or major premise on top? Yes, it is. Collectivist sign up here. So this would be second figure. So if you want to know, this is EAE second figure. But what we're doing here now is diagramming. So first we draw our circles, circle 1, circle 2, circle 3, minor term, major term, middle term. Then we identify it. Socialists, Republicans, collectivists, right? So those were the terms in our argument, okay? Then we shade. So the first one, I think the first, let me double check. No Republicans are collectivists, okay? Well, here's the Republican circle. Here's the collectivist circle. And I'm saying that nothing that's an R is a C. Well, that means that these two areas are empty, right? So we would shade, right? And remember that E claims, you always shade the intersection between the two claims, right? Go back to the previous lecture where we talked about E claims. It's always the intersection between the two circles that gets shaded in an E claim. And then we have all socialists are collectivists, right? Well, this region and this region, region 1 and region 2, would be inside the socialist column. So they're socialists, but they're outside the collectivist column. Oh, but you just said all socialists are collectivists. So that means if there are any socialists, they'd have to be here in region 4, or they'd have to be here in region 5, but they're not here, right? So we would shade that to indicate that this these two regions are empty. So when we've done all of our shading, we've shaded regions 5 and 6, and we've shaded regions 1 and 2. So when we're done shading, this is what our document looks like. Then we put our pencil down, okay? And now that we put our pencil down, we look at our conclusion, which says no socialists are Republicans. If that's true, then regions 2 and 5 should be empty. But they are, look at that, right? In other words, simply diagramming our premise set demonstrates that our premises entail the conclusion that no socialists are Republicans. Right? So we know that this argument is valid. Right? Okay, now placing an X, right? When one or more of the premises is an I or an O claim, we shade first, but then we determine where the X needs to go, right? So let's take no P are M, some S are M, some S are not P, right? So we have an E claim, an I claim, and an O claim, right? So E, I, O, and the M's are here on the right-hand side, so that is a second figure, right? But notice we would shade first, which means that region 5 and 6 are empty. But now we have to put an X, and our minor premise says some S are M, typo there. But that means an X needs to go in the intersection between the S circle and the M circle. In other words, the M has to go, I'm sorry, the X has to go either in region 4 or in region 5. But we've done our shading and we know it can't go in region 5. Why? Because region 5 is empty. Our major premise told us that. So the only place for the X to go is in region 4. Right? So that's where we would place the X, right? By process of elimination. Then we put our pencil down. The conclusion states that some S are not P. That means that there needs to be an X either in region 1 or in region 4. And there's a 1 in region 4. We know that there is an X in region 4, and thus we know that there is at least one S that is not a P. In other words, the truth of the premises entails the truth of the conclusion, and the argument is valid. But other times there can be a problem about precisely where to put the X. The following example represents such a problem. Take the syllogism. All P are M, some S are not M, some S are not P, right? This is an A-O-O claim, all right? The M's are stacked up on the right-hand side, no, left-hand side rather. So again, this is figure 2, just because I thought I'd tell you, right? But notice all P are M means that we have to shade regions 2 and 3. Fine. Is that true though? Let me double check. Yes, all P are M. But some S are not M, well, now we have to place an X, right? In order to do that, we'd have to put the X somewhere in the intersection between circle S and circle C. That should be circle M, sorry about that, right? But should it go in region 4 or should it go in region 5? Well, we don't know. So we'd have to place it on the line between the two regions. But that means we really don't know if the X, whether or not that region is, either region is occupied or not. Then we put our pencil down. The conclusion says there is at least one S that is not a P, right? For us to know that, we would have to know that there is an X unambiguously in either region 1 or 4. But we don't know that. And since we don't know that, the truth of the premises does not assure us of the truth of the conclusion. It's not entailed. This is an invalid argument, okay? Last point about diagrams. When both the premises are universals, but the conclusion is a particular claim, where does the X come from? Well, we've talked about this already, right? It depends on what type of square of opposition we're using. Put another way, are you going on the assumption that you are dealing with non-empty sets, or are you accepting the possibility that one or more of the sets about which you are talking is empty? On the hypothetical interpretation of a universal, no argument is valid, which goes from exclusively universal premises to a particular conclusion. There simply is no place for the X to come from. However, on the existential presupposition, if any circle has all but one area shaded in, an X should be placed in the remaining area. And why is that? If the set is not empty, then the only place for members to be is in the unshaded, that last unshaded area. For this reason, you are justified in placing an X in that last free area. And that's when we say the syllogism is conditionally valid, right? And so here I give you a final exercise to do, but I don't think we really need to do that. You and I, it's done here for you in the notes. So I hope this has been a helpful walkthrough of our notes. Naturally, if you have any questions, please let me know. I'm going to eventually go back and clean up my typos. And so hopefully the notes that will appear in class will have taken care of that. But if you have any questions, please do let me know. And stop sharing. Thank you for your attention, and until next time.